Okay, so today we're going to be tackling the traveling salesman problem. If you don't know what that is, don't worry. I'm going to go through and describe it in detail. But first, I just want to show you where we're starting from. So you can see I have pulled up on the screen here Kaggle.com. And Kaggle's a really cool website because it offers data sets for computer science problems. It's all open source, so anyone can contribute to these data sets, and anyone can use the data sets, which is really cool. In addition to that, they have these competitions using the data sets. Uh, so this is my first competition on Kaggle, so we'll see how this thing goes. I'll put a link into the description of the details of this challenge, but basically the idea is it's trying to solve the classic computer science problem known as the traveling salesman problem. So let me bring up ink and I'll try to describe it here. So essentially the traveling salesman problem says that you have a salesman and the salesman wants to reach all the cities to sell, I guess, whatever it is he's selling in the shortest route possible. So imagine that all these things in yellow are cities, and the traveling salesman needs to reach all these cities in the shortest distance possible. Okay. So traveling salesman can start here. You can go to this city, then here, then here, then here, then here. All right, cool. So that's one way he could do it. Another way that he could do it is he could start there, and then he could go to this city first, and then this city, this city, this city, this city. So really, what you end up with 5 cities here is he has 4 choices to start off with. He has 5 choices to start off with. 1, 2, 3, 4, 5. So he has 5 possibilities. And then once he picks a city, so say he picks the city, then he has 4 choices to go to. So even though in this picture it doesn't really seem to make sense to go down to here and then to here, that's still a possible route. And on some maps that might make sense to do. So he has really 4 options to go from here. So now he has 4 different options. And then from there, there's 3 cities left. So then he has 3 options left. Then 2 times 1. So the number of possible routes is the factorial of the number of cities. So 5 times 4 times 3 times 2 times 1. So that's 20 times 3 is 60 times 2 is 120. So even though, this looks really simple, there's only 5 cities here, the traveling salesman actually has 120 routes that he can possibly take to get to all these 5 cities. So you might say, oh, this is a computer science problem. This is easy, because if you want to find the shortest path, why don't you just brute force calculate out the distance between all the possible routes? Well, with 5 cities, there's only 120. But imagine if you have 6 cities. Imagine if I drew in another city over here. Well, now you have 6 cities here, and the total number of choices he has is 6 times 5 times 4 times 3 times 2 times 1. So it's 30, 120, 360, 720 possible choices. So you said it's a lot more. And in fact, this is known as an NP complete problem because the more cities you add, it just grows at a massive scale to the point where even supercomputers can't solve it. To put that into perspective, so if you have, let's see, if you have your traveling salesman, he wants to travel to 100 cities, and he can start from any one of those 100 cities. After that, he's 99 choices, then 98. Ultimately, this ends up being 9.33 times 10 to the 157th number of routes. So, I mean, that's, I guess, why I became an engineer and didn't go into sales. Anyways, you can see, there's a big problem here. And Kaggle, going back to Kaggle offers this data set to solve based on the number of cities. And one thing I forgot to mention is that they threw a bit of a twist into this traveling salesman problem. So they have the list of cities with their X and Y location, and I downloaded it already. So we'll look at it. So this is the cities. Let me scroll up to the top here. So the city has a city ID and then the X and Y location, just like I drew on the map on my ink pad here. It's the same sort of situation. So you've got your X and Y location, but in addition, every 10th city that the traveling salesman travels to needs to be a prime number. And if it's not, there's a 10% penalty on this distance. So the distance becomes 10% longer. So that's an interesting rule that they threw in there. For right now, we're not going to worry about that too much. We're just going to be worrying about getting the shortest distance. We'll worry about that a little bit later. But for now, I think it's really important to try to model the problem. So the way that I'm going to model this is I'm going to use a program called processing. Okay, so processing is a really cool program that allows you to do really cool graphics related things, as well as computational programs. And I like it because it's really easy to work with, and it's written in Java. So if you know Java, you can do really well in processing. So I'm going to create a new project here. We're going to save it. File, save as. Traveling salesman model. Okay, so it is saving currently. Okay, so we finished saving. So I'm going to start coding. Now, I'm going to speed through the coding sections. All the code is going to be available in the description here. But you'll be able to see it. I'll just speed it up. Okay, so I finished the program, so we're going to see what this model looks like that Kaggle gave us of the map of the cities. Let's do that now. Huh. Oh, wow, look at that. So, looks like they gave us a picture of a reindeer, and that is the map of our city, so that's kind of cool. So the next step, now that we see this map, is to connect them. Now, I said before that using 100 cities would be 10 to the 9.3 times 10 to the 157th power routes, because that's 100 factorial. Now, you can see from this map, there's a lot more than 100 cities. Each point represents a city here. So, looking at this CSV file here, I'm going to scroll down to the bottom. It looks like there are 197,768 cities here in this map. That's a lot of cities here. Let me just try that. What is that? How many possibilities? Okay, so that is a grand total of 4.7 times 10 to the 961,523 possible routes that can be taken to get to all these cities in this map. So that is that is a lot of routes. In fact, like, to put that into perspective, there are around 10 to the 80th atoms in the universe. So there's more possible routes here than there are atoms in the universe by a lot. So brute force trying out every single route here is impossible. That would never work with the type of systems that I have. But for now, what I think would be a good idea is to just try submitting a random set of paths. So connecting all these dots randomly. And basically what that means is I have a 1 in 4.7 times 10 to the 961,523rd chance of finding the shortest route. But, you know, hey, I'm a lucky guy. I might find it. But I'm going to code that up right now. Okay, so my program finished, and as you can see, there's a really efficient path that the program decided to take to get to all the cities. Um, okay, so not really. You can clearly see here there's a lot of crossovers between all the dots. In fact, you can't even see the paths in the center here because they cross over so much. And the reason for that is, this code, really all it did was it just picked random spots to jump to across the entire map to get to it. Um, but this is a submittable file, so let me see if I can bring up what it outputted here. So I had it output in a CSV format, and this is what it came out with. So each of these points here is an index of a city. So every single city was traveled to here in this CSV file. Now I didn't calculate out the distance it traveled. It was probably quite long, quite a long distance because it wasn't a very efficient route. But who knows, mathematically this could be the shortest route. So what I'm going to do now is I'm going to submit this to Kaggle and see where I place on the leaderboard. So I finally submitted my submission of the list of cities here. It took me a while because turns out there was a bug in the code. Basically, what happened was you can see I read in the string values from the CSV file, but before I was converting them all into integers because I figured it was easier to work with. But it turns out that if I bring up that CSV file, let me see if I can find it. Let me see. Yeah, so you can see here the X and Y values actually go to the thousands place, and it turns out that some of the dots were actually so close to each other that when I rounded them to integers, they were counted as the same thing. So I had to get rid of that bug, and it took me quite a while to find. But eventually I found it, and we got it all. We got all the wrinkles out, and now here we have my submission. I am in 1,134th place. So that's pretty good considering the fact that that was completely random. I beat a couple people here, probably through pure chance, that's good. I have a ways to go until I reach the top spots, but I think this is really good to just test the submission process. And next I'm going to be working on an algorithm that potentially makes this distance a lot less.